Yeah, hi, good morning. Am I audible?
Yes, Will.
Okay,
Mm.
let's get started. Okay, so today we are going to discuss Grafana Prometheus, guys, the monitoring tool for the Kubernetes, especially for metrics. Okay, let me share my screen so that we can start our practice. Mumbai. Okay, this one only. Let's connect here. kubectl get nodes. Okay, my end two nodes are there.
Veera?
So I'm going, yeah,
Yeah, are we gonna cover Helm charts or?
yes, yes.
Yeah, okay, sure. Thank you.
After complete Grafana Prometheus, we can start Helm charts only.
Okay, sure. Thank you.
Yeah. So Grafana Prometheus is a monitoring tool for the Kubernetes cluster, especially. In real time, multiple pods are running in the real time. So multiple pods means like, some cases depends on the applications, including high availability. So hundreds of pods will be run. So to monitor the hundreds of the pods, metrics for the CPU, RAM, and all, it's a very challenging role, challenging job to measure the pod resources and especially for the RAM and CPUs. And we have the tools to monitor the pods and nodes also, especially. So those are Grafana Prometheus. So Grafana Prometheus are both are two different tools. Okay, Grafana Prometheus are two different tools, and here Grafana will give a dashboard. Okay, Prometheus will collect the metrics. So two tools work together to give a one dashboard. So let's go to my blog here. Yeah. So this is Grafana Prometheus. So we are using Helm charts to install Grafana Prometheus. So, okay, what we can do. Yeah. So we will discuss Helm later after this. So we are using Helm repository. Helm is a repository where we can configure our packages or application also. For example, enter Kubernetes cluster. If you want to deploy any application inside the cluster, so usually we need to write a deployment.yaml, service.yaml, and etc. Right? But Helm is a tool here taking care everything. Whenever you can create a Helm charts, basically one sample repository, sample project will be created. The sample project inside, if you do any changes, so that those will be reflect into the pods and nodes. For example, okay, I will explain the Helm after complete this. Let me I'm just installing the Helm. Okay. After that, we need to configure Grafana Prometheus. Okay. Let me, yeah. So here, this is my cluster. Okay. Inside, for example, two nodes are running, and these two nodes inside. So for example, two pods are running. So if I want to check the pod lock metrics, the CPU and RAM here, you need to, in the last class we discussed, right? We have to install metric server and give the kubectl top pod command, kubectl top node command. We can measure, we can able to see the pods and nodes, I mean, of the metrics, especially RAM and CPU. But here I need these pod RAM and CPUs, node RAM and CPU in visualization. Okay, this visualization we can, so we can enable this visualization by using Grafana tool. Okay, by using visualization we can using Grafana tool. So but Grafana will not collect any pods and all. Grafana only give the visualization, I mean dashboard only. So here we need a one more configuration required. This is Prometheus. So this Prometheus, the job is to the job of the Prometheus is collect the log, collect the metrics. And unfortunately, Prometheus is not a tool to provide a visualization. Just collect the information from the cluster only. So this Prometheus will give work like a source for Grafana. So this Prometheus work like a source for Grafana. I mean, to visualize the metrics and something, Grafana needs some source. So Prometheus will hand over this metrics to Grafana, and Grafana will give a visualization format of the pods and nodes and RAMs here. Okay, I mean the job of the Prometheus is collect the metrics and hand over to Grafana. So by Grafana itself, it is not possible to collect the metrics. Grafana is a just only visualization dashboard. So someone has to collect the nodes and hand out to Grafana, that is taken care by Prometheus. So Grafana Prometheus is a monitoring tools for metrics. So monitoring tool, both pod and node. Okay, so let's install the, it's a very easy process only, just installation only. You can install through Helm or directly. So how we can install metric server and all kubectl apply -f, the GitHub URL link. If you apply means the background, no, the metric server is created, right? Same thing here also. If you go through that process, you are able to install Grafana Prometheus through GitHub itself by applying the kubectl command, or you can install through Helm also. Helm gives the packages directly by installing the Helm also. So let me first my end Helm is there or not, we can check here. If I have a Helm here, yeah, Helm hyphen version. Okay, so my end, okay. Okay, my end Helm is there. So how to install the Helm? So you just go through this also. Just only three commands are my end also the nodes I'm going to provide here to installation of Helm. Control F. Okay. So yeah. So you can go through this Helm process. So by using wget command and install Helm. Okay. These packages, if you install, you are able to install Helm. And after that, excuse me. So after that, we can, after Helm version, we can just start the process. So here, my end Helm is already installed. So this is actual very low level architecture Grafana Prometheus, how it will work. So no need to focus here that much of level. Even just Grafana Prometheus, how it will work the background. So here we need to understand. Install Prometheus and Grafana using Helm. Prometheus server to process and stores the metrics data. And alert manager sends alerts to system channel anyway. Grafana visualize the scrapped data and UI. I mean, Grafana will give the UI. So now why use the Helm? Helm is a package manager for Kubernetes. Helm simplifies the installation of components in the one command. Install using Helm is recommended. So if you want to install any packages, so we have a Helm. Simply we can install by using package manager Helm. So here just Prometheus is a open source monitor tool to collect the store metrics, time series data and all. And here Grafana is a open source visualization tool, allow to query, visualize, alert, explore your metrics no matter where they're stored. I mean here, what are metrics Prometheus is collecting that will hand out to Grafana. Grafana will give you a visualization dashboard. So I'm going to install I'm going to install Grafana Prometheus by using Helm. So I'm going to add a Helm repo here. After install Helm only, you need to do this process. Okay, my end already exists. Okay, no problem. So let's go to Hagen. So I'm going to add the Prometheus. I'm installing Grafana Prometheus through Helm only. This request will go to Helm repository and it will be installed. Sorry, not here. Okay, my end Prometheus also there. And now, so we are going to create a namespace. So already we know the namespace, right? So I'm going to create a namespace. Everything we can work with this namespace only for Grafana Prometheus for better understanding. So created namespace for Prometheus. So yeah. So I'm going to install the stable version of Prometheus and Grafana by using this command. So Helm is installing the, excuse me, Grafana plus Prometheus also, the stack. So it will take some time. The both Grafana and Prometheus will install the pods and all the background. So it is installing. If you want to check, you can open one more duplicate tab here. You can check here. The required pods I'm checking the namespace of Prometheus. I mean, whatever you can install in the Kubernetes, everything will be installed in the form of pod only. So Grafana pod, Prometheus pods will be run the background. Okay, pending state. The reason my and nodes are not there. So what we can do here, let's go to the where exactly the cluster is running. I think Mumbai. So let's go to auto scaling group. Okay, let me change these nodes to 4. Yeah, it is. Those are running now. Okay, sorry. So yeah, let's go now and check now. Excuse me. Okay. Okay. So okay, it will I think take some time. We can proceed now. Only one pod is we don't have any problem. And so now I'm going to check the service of the Prometheus. The reason um, whenever you can install Grafana Prometheus, the background service and everything will be created. Same namespace, we need to check the reason everything will be installed in the same namespace. So if you can see here, my Prometheus, okay, and all are if you can see cluster IPs only. But if you want to access your Prometheus, first you need to change it into node port. So in this case, what we need to do here? So let's go to and enable node port. See, through load balancer or node port, you can access your Prometheus, but by default, it is on cluster IP. I'm going to now edit the cluster IP to node port. So I'm going to edit stable Q Prometheus, STS Prometheus. So if you can see here, this one, I'm going to edit. So this one we can access from the external so that we are able to see Prometheus dashboard. So cube CTL edit SVC. So we can give here this one, copy cube CTL edit SVC. Yeah. Sorry. We have to give hyphen and Prometheus, right? Everything is running in Prometheus namespace only we have created, or you can run on default also, no problem. So here, just down here, done. So edited. So whenever you install Grafana Prometheus, so by default Grafana Prometheus will be created, but the background service will be created through cluster IP only. So if you want to access from external, you need to be changed into the node port or load balancer. Now you can give the same command kubectl get svc hyphen and Prometheus. Yeah, now we can see my port number is 30568. So we need to check the nodes hyphen wide. So yeah, these are my nodes, or simply we can take any one of the node here. So any one of the node you can take here, public IP of the node and give here the port number 5030568 of the Graph Prometheus. See, I'm able to access my Prometheus. Okay, sorry, call got disconnected. Let me share my screen now. Okay. So we are here now. So I'm able to access Prometheus dashboard now. This is Prometheus dashboard. So if you want to run any query, we can execute the query. So it will collect the information from the nodes. Anyway, these are running into your cluster itself only. The job of the Prometheus is to collect the metrics from the nodes and the pods. So then now, okay, the Prometheus is good. Now let's go to Grafana installation. I mean, Grafana configuration. If you can come little down, change it from cluster IP to load balancer. After changing make sure you can save the file. So I'm not going to enable load balancer. Grafana also I'm going to go with node port only. So let's go to enable the Grafana after Prometheus. Just go for Grafana now. Let's come now. Yeah, so this is my Grafana. So if you want to check here also, we can see stable Grafana. So kubectl get svc hyphen n Prometheus. Okay, spelling is wrong. Okay, so this Grafana also cluster app is running. So I'm going to edit this one. So kubectl edit svc -n. So Prometheus. Sorry, Prometheus. So this file also I'm going to change now node porter load balancer. So load balancer is chargeable. So I'm just for accessing purpose, I'm going with node port. Okay, editor now. So let's check now kubectl get svc hyphen and Prometheus. Everything is running in Prometheus namespace. Prometheus namespace is your wish. You can give anything, no problem. So one more node port is ready, Grafana 31093. So you can take 31093. So I mean, you can take IP, any IP you can take it, any node IP. The reason service will run cluster level 31093. So I'm able to access Grafana also now. So by default, Grafana username is admin. So the password, again, you can go for password. You need to get secret. So the password will be stored here. So if you run this, so from the secrets, you are able to access, you're able to get the secrets of the Grafana. So I'm using echo, the promo operator is the password. Yeah, finally, this is Grafana dashboard where we can configure the dashboard and all. So yeah, so this is what we need to do. Go to home here. There is a import dashboard. Click on dashboard. Here we can go for import option. So here, guys, Grafana dashboard, we have a different templates. I mean, these are working with different codes. For example, if I this so in my here the blog, I'm using this code number 15760. I mean, this is for just different view only. If I give this code, I'm able to see the different view of the metrics and logs. I mean, metrics. If I give different code, I'm able to see different, I mean, the metrics we can see in the flow charts, or maybe we can see in the circle format. Whatever the concept is same, these codes are default codes to give the visualization in different format. So for example, if I give 15760 code, so we need to give the load here. And after that, what is the source of the Grafana? So Prometheus, select this one and then import. See, we are able to see the your pods and nodes details here. So total pod CPU 12.14%, total pod RAM 862%. So total pod RAM in, I mean, we have a different pods, right? And here, if you can see, my namespace is default. If you can check the namespace is Prometheus, I can see different, different CPU, different memory. I mean, if I select namespace, if you select default, so my and many pods are running in the default namespace. I'm able to see here. See, if you want to study respect to pod, if you want to check the respect to pod here. So here, these are the pods. You can check MySQL 0. Give here. We are able to see MySQL CPU used and memory used here. So like that, if you want to check all, you can check all and give here. We are able to see all the loads. Clear or any questions?
Clear.
What about
Clear,
this is
Vira.
very important in entry point of view. The configurations, no one asks how to install and all, but the importance is the how to get the pod information, how to check the pods information here is the important. Okay, the final concept, guys. The final concept is Helm. Okay, let's go to Helm. So my end already Helm is installed. Just give me some time. I think here is delete. Okay, no problem. Yeah, here is only there Helm charts. So this is a Helm install process. My end already install. You can go through this process to install or whatever. The blog itself also we have a Helm installation process. So Helm is a tool that automates the creation, packaging, configuration, and deployment of the Kubernetes application by combining your configurations files into the single reusable package. I mean here, if you install, sorry, if you create this command, just simple command if you can give, we'll see what will happen now. My end already Helm is there, so no problem. So if I give this, creating hello world, Helm create hello world, ls. Yeah, if you can see hello world is here. I just given command is helm create. So let's go inside hello world now. ls and give the tree command. So we can see the list of files here. So I just given helm create hello world or helm create any name you can give. No need to give only hello world. You can give any name. Helm create. So what Helm will give here? Helm will give here sample, okay? Sample code, sample project template. So if you can see, for example, developers develop the code. So if you want to run in Kubernetes pods, we need to write a deployment.yaml, image push to easier. So from there to we can pull the image by using deployment.yaml and service.yaml, we can give access. And hpa.yaml, we can give high availability pod level. Ingress.yaml, we can give ingress different paths you can access. So we have a different process here. Okay. So what we can do here. So yeah, if you can see, whenever you can create a Helm, create some name, Helm will create this flow, this template. I'm not creating this template, Helm is creating this. So if you create Helm, Helm will give a sample Nginx project. Okay, sample Nginx project. This sample Nginx project, okay, this sample Nginx project will gives one basic, Nginx application deployment template. So if I run this project now, I'm able to access Helm directly. The reason, so Helm image they are using for deployment at YAML for the sample application. But here, how we can organize these many YAML files haven't created, but Helm is created, right? So Helm created these templates by using variable process. So here there is a values.yaml, right? By using this values.yaml only, we'll insert the values into these templates. For example, deployment.yaml, if I can check, in their deployment.yaml, there is no any hard-coded value. So in general, deployment.yaml contains what? Image details or replica details, right? But if you can go in deployment.yaml, nothing is there, that is variabilized. But for the to deployment.yaml, values we can pass from the values.yaml. I mean, this is the very important YAML file from where we can insert the values to this deployment.yaml, service.yaml, ingress.yaml, and everything. So this is the main YAML where we can give the values. From here, it will be inserted into the respective, YAML files. So whenever you can create a Helm project, no need to create any deployment.yaml, ingress.yaml manually. This YAML files already created behalf of you. The Helm is taking care. So now how to run Helm projects, how to manage the Helm projects here. So yeah, you can, so just sample, you can go for my blog again here also. So we have a Helm also. Okay, writing a sample Helm charts for Hello World, if you can see. So first Helm create Hello World. So whenever you can create a tree, if you can check, these many template is created by default. So whenever you can create a Hello World, Helm will give a sample application, Nginx application. Okay, and if you can see, great. Now you created a Helm first Hello World chart. In this, we are going to run the Hello World Helm charts, update the service types, and everything we can manage in the Helm charts itself. Okay, let's go now. We can discuss one by one. So here, deployment.yaml, where we can give the image, hpa.yaml, so where we can give the high availability across the pod level, ingress.yaml, so we can give a support for different paths, service.yaml, so how to access the pod through cluster IP or node balancer, load balancer. Okay, service account not acquired, we are not using it all. So now ls, okay, this is clear. Now, if I go here, CD template, the work is here only, the CD template only, ls. So here I can see number of YAML files, hpa.yaml, ingress.yaml, service.yaml, deployment.yaml. So if I go and check the deployment.yaml, so this is deployment.yaml. If you can see, same our deployment.yaml only, but no value is hard coded, everything is variabilized. So in the Helm, we are writing variable in this format only. Open two curly braces and close two curly braces. In between, you can write anything. Okay, let's understand. This is my deployment.yaml. So here we need to check where exactly image is updated. Okay. So here, this is my image. So my image is calling from where, guys? Dot values, dot image, dot repository. Dot values, dot image, dot repository. And here my container port is calling from where? Dot values, dot service, dot port. Everything we are calling from the dot values and something. Node selector, if you want to give node selector, node affinity, tolerations, everything is there in the same pod YAML only. So if you want to give any volume, if you want to enable node selector, if you want to enable affinity, simply this respective area, you can go and update it. For example, now, as I can see, my image is calling from values.image.repository. Values means, as I discussed, values.yaml. Let's go there now, ls. See, one step back here, values.yaml is there here only. So let's go and check now my image. I'm passing from here only, right? I'm giving image from here only. So if you can see my image, okay, dot values, you are inside of the values, right? Dot values, dot image, dot repository. So these three I'm already calling in the inside deployment YAML, right? So if I call, the meaning is this Nginx is calling from here, dot values, dot image, dot repository. Okay. Replica count. So if you are using replica count, dot values, dot replica count. So for example, if I'm calling any different, yeah, if I'm calling, for example, port number, dot values, dot service, dot type, dot values, dot service, dot port. Like that we need to call. This is enter values.yaml. So again, if I go here, VA, sorry, yeah, ls cd template, ls vi deployment.yaml. So replica count. replica count, yeah, here. See dot values, dot replica count. Like that, we can insert the values from directly values.ml only. So same thing, if I go and check the service, VA service.ml. Sorry, quit. So VA service.ml. Yeah, so service.ml, service.ml, we have a selector. So selector, hello dot selector labels. So port number values dot service dot port number. So here I'm calling the things from the directly the values.ml. Okay. So this is the concept. Now Helm is created with the sample project. So simply we can change the values.ml. We can run the process. Okay. So let's go to now start the process now. So if I'm going to install Helm, so if I want to run here, so you need to be execute Helm like this only. But one thing we need to understand here, let's go to my service.ml. So vi values.ml. So I'm by default, Helm also created a service in cluster IP only. So I need to change it into node port. So again, no need to go anywhere. Simply you can come here. You can change here only values.ml only. See, that is taken care by your Helm. Done. So now you can run the Helm. How to run the Helm? So this is the process we need to follow. To run Helm chart, you need to use the command Helm install command to run a Helm chart. But here we can see first argument, second argument. Second argument is a chart name. So my chart name is hello world, right? So first argument release name, we can give anything. I will tell you the reason why. So Helm install. And a very important thing is my Helm chart name is hello world, right? So you should come out the hello world. So you can see you need to run the project. You are exit from the hello world only. So Helm, the reason Helm will run entire project. So if you are inside of the project, Helm will not run. Helm install first release. I'm giving the first release. You can give any name, no problem. Or I'm giving the release one. Release one of hello world. Okay, done. Now you can use kubectl get svc. If you run this command, we are able to see my release hello world node port 31167. Copy 31167. Welcome to Nginx. So my Helm inside Nginx image is there. Helm is going to run. So you can do some further modifications here. For example, cd hello world. Go inside now. One pod is only running. I want to create two pods. So simply go to values only. No need to go anywhere. If you want to do any changes, simply go to values.ml. So these values will be picked from here to your deployment.ml. So my replica is 1, right? Now I'm going to give replica equal to 2. Save. And again, you can exit from hello world to run ls. Again, run helm. So if I run here, see installation failed. we cannot reuse the name that's still in use. So if you do some modifications, na, what you can do, the modifications is not install, right? The command is upgrade. Okay, upgrade means modification, install means create a project, upgrade release one hello world. Done. Now kubectl will get pods. See, this time I'm able to see two pods are running. So like this we can, you can run helm list -a command to check the list of releases. So my list of releases are two. First release is some changes, second release are different changes. Again, you can change if you want to do any changes here. Values.ml. Sorry. You should go to hello world, vi values.ml. So again, you can change 2 to 3 or 2 to 1. And again, you can run the helm upgrade command. But if you want to run, you just exit from hello world and you can run. Upgrade means modifications. Kubectl will get pods. So you can find out here also these running pods. Now, if you can go here, the namespace is default, right? If you can see all pods, yeah, I'm able to see release one, my pods. Hello world pods, I'm able to see. And now ls cd hello world. Here chart.aml is play a very important role, guys. This chart.aml only will run entire projects. If I go chart.aml inside, see my project name is hello world. So whatever project name you are creating with that name, one AML file will be created. So this AML file will take care to run the project, to create a project and whatever it is. Okay, the naming and everything, the name of the project, whatever you are given on that name, chart.aml will be created. Okay, so this chart.aml maintain the metadata of the project, the version and name and all application. So clear or any questions? So only three commands. Helm create is the command to create a project. Helm install is to run a project. Helm upgrade is to modify the project. Three commands only. So if you want to do any project, simply in place of Nginx, you can give your image from the ECR path or Docker path. Any questions?
No,
Now
very
it is
clear.
clear.
Yeah. So we need to understand here, for example, ls cd values, sorry, vi values.aml. So if you want to do any changes here, give the different image. You can give HTTP image or whatever. Otherwise, let me give my image. We can do our custom project. Docker Hub. So Helm project. Sign in. Okay. Let's take this Vira Nani's master I'm taking here. Copy and go here. Insert. Not required 3. I'm just giving only 1 for understanding here. Or you can give 3, no problem. No problem. So repository I'm giving here. Paste here. Let's calm down now. The port number, my Node.js is not 80. So I'm changing to 3000. Let's if you want to run different project, you can run. I mean Helm. I mean release without disturb that. For example, so if I run instead of upgrade, if I run Helm install release 2, so both will run. Nginx will run. Now your Node.js application Hotstar project also will run. Or if I give release 1 as is, if you give upgrade means the existing pods will be deleted and new pods will be created for new application. Let's do it now. Okay, you should come out from here. Hello world. Now my image is different. Created. So kubectl get pods. Kubectl get pods. Oh, error image. Okay. Kubectl, how to check error image? Kubectl describe pod and check the pod name. If you observe here one thing, my existing pods will not deleted first. This is Nginx image. After create this own new image only, these will be deleted. The reason, same application, if you want to upgrade the version, new release is there from the developers. In this case, old release should work until up new release. So after run the new release only, old release will be deleted. So new release, some issue is there, still old release will work. That's what. Now give here what happened to new release. We can check here. Pulling image Vira Narni. Okay. See guys, if you can see my image is wrong. I have given only Vira Narni only. Hotstar only, but 1.16.0 is coming here. I haven't given here. So what we can do here, let's go to my Helm chart so that I can understand why it is printing here. CD hello world ls. So CD templates, my deployment YAML, right? The value is inserting is correct, but additional value is appending here. So vi deployment YAML, I can check my appending value is here. The image section is, where is the image section here? Yeah, no. So guys, if you can see my image section, the additional parameters also there. Chart application, chart app dot version, chart app dot version. For example, this chart dot app dot version means it is calling from chart.aml. Okay. Duplicate tab. Okay. Need to log in. Okay, ls cd hello world, cd charts, ls, sorry, hello world, ls. So yeah, vi chart.ml. So it is calling from app version is calling from chart.ml. So here app version is calling from here. So for example, the reason of this is metadata. Chart.ml is metadata of your application. For example, guys, if I push my image, there is some version 1.2 and something. Here simply you can update the app version 1.2. I mean your image 1.2, image 1.3. So this 1.2 will take from app version. That's what deployment.yaml is, image path and append your app version also. But my image, there is no app version, right? So that's what I can do now. ls cd charts, ls, sorry, cd template, come back, cd templates, ls. So if you can see here, I'm going to take care vi deploy.yaml. See here, I'm going to remove this image. Sorry, insert. Simply, I'm just giving my image path only. So it will not take any app version now. Okay, let's come now back, one step back now. Let's run again upgrade command. So Helm upgrade. Yeah, Helm upgrade release one hello world. So kubectl get pods. Container is creating. Once container will be created, these 3 pods also will be deleted. These 3 pods will up and run. Still container is creating. We'll see. Meanwhile, if you want to check logs, kubectl logs of this pod, okay. So kubectl get pods now. Still container is creating, something is wrong here. Kubectl describe pod. What is taking this much of time? Liveness probe is failed, readiness probe is failed. Okay, there is again something condition they have. I think they put some condition, liveness probe and readiness probe. These are just probes for to check only. For example, my pod has to be created in 5 minutes. Sorry, 5 seconds. Whenever you can apply command is given. If the pod is not run in the range of 5 seconds, this probe will fail. It will not allow to run a pod. These are just pre-checks. Readiness probe is for pre-checks, liveness probe is for after install the pod only. After run the pod only. Okay, anyway, not at all require these probes. I'm going to again bypass these probes, ls, vi, again go to deployment, hello world, ls, so cd templates, ls, VI deployment.aml. So the readiness probe is for Nginx, right? This is different readiness probe. That's what the error is. So what we can plan here, you can comment or delete the readiness probes and all. Yeah, these are liveness probe, readiness probe not required. You just remove these two or comment this one. Again, you can cd dot okay, then you can check again kubectl get pods. See running now. See now, these three terminating. These are old one. Now three are running. These are new one. I mean, old version is deleted whenever new version is created only. So always your application is up and running, right? Yes. So you can access now. Let's check SVC. kubectl get SVC. Yeah, the node port, same node port. Okay, 31167. Yeah, see, running my sample application. So the benefits of the Helm, see, no need to write deployment.ml, no need to write service.ml, no need to write ingress, whatever. So we can test replica count also. Simply horizontal pod also we can test it now. So if you want to test horizontal pod auto scaling also, cd hello world, you can go here, ls cd templates, go ls, see go vi ingress. These are little advanced topics, yes. So if you can go here, my ingress, sorry, not ingress, right? I need to check. Even ingress also okay. HPA.ml, right? Yeah. So if you can see, this is my HPA.ml minimum maximum set points here. If you can see average CPU utilization calling from auto scaling target memory utilization percentages. So we can mention there over there also. So minimum set points, maximum set points. Simply we can calling from there only. See values auto scaling dot minimum replicas. Let's go now. We can check. So ls cd back vi values.ml. So here there is a set point auto scaling group. You can see here. Yeah. See auto scale values dot auto scaling group dot minimum replicas. Values dot auto scaling dot maximum replicas. So simply we can change here. Percentage is 80%. If I give 1%, same pods will be created. Max replica is 100. So 100 pods will be created. So this is the story of long story short Helm charts. This is very important, whoever going to apply 5 years, 6 years on only Kubernetes, they will ask this kind of questions. So any questions? Are you clear?
Clear, Veera.
Yes, Viraj,
Clear.
clear.
Okay, so that's all Kubernetes. Anything is required on Kubernetes, so that you can let me know. I will cover even. But enough, no need to learn these many topics also. But still, if you are looking for any concept on the Kubernetes, do not hesitate. So you can ask. I will cover. If you're okay means I need to start from Helm. I will show you one sample project, end-to-end project by using Jenkins and Argo CD tomorrow. and then we can go for Ansible. So I will complete Ansible in 4 days only, 4 to 5 days. No need to go depth. Reason Ansible is only useful for system configuration engineers. So the DevOps, especially for the microservices approach, Ansible scope is very less. Okay, are you clear? So that we can.
Yes, we're clear.
Okay.
Veera,
Yes.
can we check logs using Prometheus?
No, not possible. The reason Prometheus will give only metrics. For the logs, we have a one more concept. It's a very, very big concept. So if you guys are really interested to get the pull the logs after practice Kubernetes only, you can just go through this. Not now. The reason having multiple YAML files. So this is the project EFK stack. Okay, EFK stack. So this is Kibana dashboard to pull the logs. Fluentbit for install the node exporter. Elasticsearch is kind of database to store the logs. So in this case, you need to work with these three to install the logs and everything here. A lot of files are there. So first, after practice, you guys need to practice this EFK stack if you want to pull the logs also. So this is the dashboard of the logs. We can see here. Check the pod, we are able to see logs here. No need to go inside of the cluster. Clear? See, whatever we discussed till now, only those concepts only there. Sir, they are using daemon set for Fluentbit. Fluentbit is what? Fluentbit is a service to get the logs for all the pods, all the nodes. Why all the pods, all the nodes? Daemon set will whenever you can whenever you can apply daemon set, each node one pod will be created, right? So they are using daemon set kind for Fluentbit, like that. So whatever we discuss in the Kubernetes, everything will be covered in this EFK stack only. Clear?
Yes, Veera, it's clear.
Yeah.
Okay.
Yes, I think there is a question. Okay, then we can close the session. Thank you so much. We'll discuss tomorrow project. At least it will take 2 hours time. So, okay, bye-bye.
Thank you, Veera.
Yeah,
Thank you, Vera.
Thank you, Veera.
thank you. Bye.